Hello everybody, this is Math 140, day 11. I hope you all got over the exam shock, have recovered. And now we need to move on and go to module 4. No time to lose. Module 4 is about quadratic equations. A lot of it. And this time we're going to talk about quadratic equations where these simple ways of solving them do not work anymore. So this is about the quadratic formula. Also known as the midnight formula. For solving quadratic equations. And to begin with, a quadratic equation looks like this: ax squared plus bx plus c equal to 0, or it can be rewritten in that form with the quadratic coefficient, the a, non-zero. If that was 0, it would make it a whole lot easier. It would be a linear equation, and we have dealt with them. So now let's take a non-zero quadratic coefficient. And to solve that, if we are just trying to do that by hand, we could factor out the a by brute force. Like this. I have a times x squared plus b over a x plus c over a equal to 0. And since the a is non-zero, the parentheses have to be 0. And then we want to form a perfect square. So we look at x plus b over 2 times a. When you square that, you got to FOIL it out. Think x plus b over 2a times x plus b over 2a. And just to be safe, I'm going to write it out. And I get an x squared for sure. And then I get b over 2a times x, and I get an x times b over 2a together. That's b over a times x. And finally, I get b squared over 4a squared. So that complete square, that perfect square, matches the x squared. And it also matches the b over a times x. It only doesn't match the constant term. But we can fix the constant term. So x squared plus b over a times x plus c over a is equal to that perfect square minus b squared over 4a squared plus c over a. And we want to investigate, when is the whole thing 0? Well, it happens when the perfect square, x plus b over 2a, quantity squared, is equal to b squared over 4a squared minus c over a. I'm going to rewrite that with a common Denominator, we've done those, remember? Common denominator 4a squared. Numerator is b squared minus 4ac. And now I'm going to try to take square roots. X plus b over 2a is the square root here, equal to the square root of the whole thing, divided by 4a squared, the whole fraction. But remember, there was a practice exam problem where this led to a mistake. Namely, the square root is always the non-negative answer. And of course, that x plus b over 2a could be negative. So we've got to put a little plus minus sign. And then everything is actually true. We only want to simplify that square root. Square root of a fraction is the fraction of square roots. So we got the numerator square root of b squared minus 4ac. And denominator square root of 4a squared is just 2a with the plus minus sign taking care of the possibility that 2a could be negative. So that all gets gobbled up by the plus minus. And finally, we subtract b over 2a from both sides and we get x is negative b plus minus square root of b squared minus 4ac divided by 2a. And now I can box this in red because this is the quadratic formula or midnight formula. Why is it called midnight formula? Because if someone wakes you up at midnight, shakes you, and asks you what is that formula for solving quadratic equations, you need to say, okay, it's negative b plus minus square root of b squared minus 4ac divided by 2a. That fast. You got to remember this one because during an exam, there's no time, and it's prone to errors in redoing all that, reinventing the wheel. That's not the point. Why did I even do that in lecture? Because I think it's a really good exercise in algebra. And it shows you that it's not so impossible to actually discover this formula. So I did that just this once. But for actually applying it, you go straight to that red boxed formula and apply it. So let's do some examples. I got examples. The first one, a simple one. X squared minus 3x minus 10 equal to 0. So let's match up what do we have with a, b, and c. Our a is the quadratic coefficient, 1. B is the linear coefficient, -3. Constant coefficient C is -10. We plug this into that midnight formula and we get x is -b, the opposite of b, and that is +3, plus minus square root of b squared is 9 minus 4ac, that's +40. Divided by 2. The plus minus gives us two different choices. So what if we have the positive choice, the plus? That's 3 plus 7 divided by 2, which is 10. That's 5. Or x is 3 minus 7 divided by 2, which is -2. And I said this is a simple example because I could have factored this equation by hand by trying factors of -10. X squared minus 3x minus 10. I would have found it's x minus 5 times x plus 2. And then you can just read off when x is 5, we have a solution. And when x is -2, we have another solution of this thing being 0. So when it's an easy equation like this, the factoring is worth it. You try that. The trouble is that sometimes the factoring doesn't work and the solutions are just more complicated. So that's the second example. And I got x squared minus 3x minus 11 equal to 0. So here, a is 1, b is -3, c is -11. And my midnight formula tells me x is 3 plus minus the square root of 9 plus 4 times 11 minus 11, so plus 44 divided by 2 times 1. That's 3 plus minus the square root of 53 divided by 2, and there's nothing we can simplify here. Just leave it. Do not whip out your calculator unless somebody explicitly asks you to. So leave it alone. This is called an exact answer. For one thing, because it's exact, it's exactly right. And to emphasize, whenever you take out your calculator and the calculator calculates a square root of 53, they will round this off because there's infinitely many decimals and they do not follow a pattern. So it will always be rounded off and you can't write down an exact solution for this with decimal fractions. So don't do it if you don't have to. Just leave this, it's fine. Okay, so that's my second example, more complicated, when you really need the midnight formula. Or quadratic formula. If you had tried factors of 11, -11, well, there's 1, there's 11, and -1, -11, and none of them would have worked. So if this ever happens to you, do not give up. Just go to your quadratic formula if you didn't try that in the first place. Okay. Now there's a third case, and that has to do with what if we get a negative number under the square root? And I'm not going to do that today. I'm going to leave that for another day because it leads to the topic of complex numbers. There's a lot of problems in this module about complex numbers and the number I and simplifying complex numbers. And let's just wrap this up, box it, and leave it for another day because there's enough with problems where this works, where you can do them, and I want to do something else. So wrap it up, leave it at this, and don't do the problems with complex numbers right now. We'll talk about them on Tuesday.